Okay, so here we have a 3D pyramid, a bit of 3D trig, and these questions are quite tricky, and I have to say that this one is very tricky indeed. They've given us the total surface area of the pyramid, and they want to find the angle that AC makes with the base. So I'm going to make this triangle, this 3D triangle, this triangle that's standing up. Okay, put the 90 degrees in to help us try and see what I'm looking for. And they want the angle that AC makes with the base. Now that base, I can work that out how long it is, because O's in the centre of this 10 by 10 square, so it must be a little 5 by 5 right angled triangle there, and I could work out the hypotenuse of that little 5 by 5 triangle, couldn't I? And if I did that, I could work out the base of the line O to C out of the triangle that I actually want, the upright triangle. So 5 squared plus 5 squared square rooted will be 5 root 2, won't it? There it is, 5 root 2. So we know now that the triangle that I'm interested in, which is the angle that AC makes with the floor, the base, okay, I know that that particular triangle here has got a length of 5 root 2. I now need to find either the height of the pyramid or the length of the line AC. Now I haven't, unfortunately, if I'd been given the volume I could have easily found the height of this pyramid, but I haven't. I've been given the surface area. So it says the total surface area as well in bold, so that means that the base is included. And the base of course is 100 centimetres squared, so I can take that away from 360, and that's going to give me 260 is the surface area of the sides. And of course there's 4 sides that are all triangles, so each triangular side has an area of 65. So what I'm going to do is I'm going to go up here and I'm going to say that I've got a triangle that's got a base of 10, it's isosceles, and it's got an area of 65. And why would I want to do that? Because that would give me the height. I know the height and the base of this particular triangle will tell me the length of AC eventually, because I know the area is 65. Now half times the base times by the height is the formula for the area of a triangle, which I know is 65. And so that you can see I've got 5h equals 65, so h is going to equal 13. So I've got a triangle that's got a height of 13, a perpendicular height of 13, and a side length of 5. So Pythagoras will let me work out the length of AC now. So what's that going to be? It's going to be 13 squared plus 5 squared, all square rooted, and that's going to equal the square root of 194, isn't it? But I will check on my calculator. 13 squared plus 5 squared, yep, 194, and I need to square root that, and I don't think that's a nice square. No, it's not. No, third. So it's just the square root of 194, but that's the length of AC. So I can go back to my actual triangle that I've been working on, and now I've got 2 sides, and that's enough to be able to find the angle between them, because it's a right angle triangle. And of course they've got the adjacent to the angle, I've got the hypotenuse. So the adjacent and the hypotenuse is a cosine question. So let's write down what I know, that the cosine of the angle will equal 5 root 2 divided by root 194, and of course to get rid of that cosine, just to find the theta by itself, needs an inverse cosine, so theta is going to be equal to the inverse of cosine of 5 root 2 all over root 194. Okay, so if we do that, that should be the answer to our question. So the calculator gives me, sorry about that, a bit slow there. Yep, 5 root 2 all over root 194 gives me an answer of 59.5 degrees to 3 sig figs, which is what they actually wanted. Okay, and so there's my answer. So I think that was an extraordinarily hard question actually. I don't think I'll get much harder than that. Let's see what the examiners thought. Yes, yeah, it was a very challenging question. Yeah, I thought it was a toughie. In fact, when I did this question the first time, I had to stop because I was thinking I'm using A-level maths here, so I had to make sure I did it in a way that you could do it for GCSE. So yeah, I've done the same thing there. Tough question. 59.5.